Hello, it's Keith here, and this is lesson 15 of the platform-specific series of my 68,000 assembly programming tutorials. We're looking at palettes again, and this week we're going to be looking at how to set up colours on the Neo Geo. Now, the Neo Geo has a very advanced set of palettes and a very good colour definition, whereas a lot of systems are limited to 16 or 32 colours. The Neo Geo has 16 colours per palette and a massive 256 palettes. Now, each of these palette entries takes a single word, so 2 bytes, and that word is split up a little oddly, but it effectively uses 5 bits per color channel, and it has 1 extra bit for something that's a dark toggle. Now, we're going to go into this today, but you do have to bear in mind that there is a special color as well. There's what's known as a reference color, and this is a fixed color that we have to leave alone. And also there is a background color, which is a sort of common color for the transparent layers, and this has a special position as well. So the entry at hexadecimal 400,000 needs to be left at 8000, and the one at 401 FFE is effectively the background color for the entire system. So those are special colors. Now, within these tutorials we only use 16 colors, so we're effectively going to use palette 1 for everything. So palette 0 is going to be left alone because of that special entry, and we're going to be using palette 1 in most cases, but we are also going to have to set that background color as well when we set color 0. Now, when it actually comes to setting a color, of course we can work out the position of our color just by working out the color number within the palette and multiplying it by 2, because there's 2 bytes per color. Now, the color entry definitions themselves are split into 2 parts. Effectively, we've got 1 nibble per channel, red, green and blue here, but then there's an extra bit that can make up a least significant bit, and you can see the red, green and blue bits are in the top nibble just here. Then you've got the final bit, which is also used, and this is the dark bit. If we set this, it effectively lowers the brightness of the entry. I think this is essentially for the pausing mode that you often see in games. When you pause the game, the screen will become darker temporarily, and I think this is an easy way to make all the colours dark and then reset them all once the pause is disabled, because I don't think it's really going to be necessary on a 5-bit per channel colour definition to have this dark bit to do anything. But anyway, if you've seen these tutorials before, we use a common definition. We use 1 nibble per channel, and we use a green, red, blue format, whereas this uses a red, green, blue format. So we're going to have to swap those nibbles around, but we don't have any data for these least significant bits up here, so we're simply not going to use them. Now, of course, if you were writing a game only for the Neo Geo, then you would possibly want to use that extra bit and use a native format color, but because these tutorials are multi-platform, we're sticking to cross-compatibility rather than using all of the functionality of the Neo Geo. Anyway, let's see today's example and we'll learn how it works. So we've seen it before. This is our standard chibi code bitmap on the screen. We can see it just here, and we're going to be defining the colors here in today's example. Now, what are those colors? Well, you can see them just down here. The first color is the background, which is black. We then got a purple here, because you can see this is in blank, green, red, blue, 1 nibble per channel format. And so the green is 0 and the red and the blue are 9 here, which is a sort of mid-range, and that makes it effectively a purple. Then we've got a large amount of green and full blue here, and that makes cyan. And then finally we've got white here. So this is the colors that we're defining for today's example. And the way we use these colors in our code, well, you can see it just here. All we're doing is we're reading in a word from the definition we just saw into D1. We're setting D0 to the palette number, and then we're calling this set palette function here. So if we've got the palette entry set to 0 and we've got all 3 nibbles set to F or 15, then we will be effectively setting color 0 to white. Now, that's how we're going to be doing things, and it's the code here that does all of the work. Now, as I previously explained, the first palette isn't really so appropriate for us, so we're going to start from palette 1. So our start entry is going to be 40020, which is the start of palette 1, because there's 16 entries per palette and each color entry has 2 bytes. So the first palette after palette 0 starts at hexadecimal 20, 32 bytes in. Now what we're going to do is we're going to take the color number we want to change. So we're just masking off any unused data here. We're then rotating it to the left by 1. This effectively doubles that number, because remember there's 2 bytes per color entry. We then add that value to the offset here, and that gives us the destination for the new data. We just store that in a 0 for later. Now what we need to do is we need to shift around our data here. Now, our definition for these tutorials has the green entry here, the red entry here, and the blue entry here. Now effectively what we need to do is we need to swap the red and the green entries around. The blue entry is in the correct place, and you can see that represented in the code here. Now we copy our definition here into D3, then we take the bottom nibble and we store it in D3. Then we copy our palette definition to D2. We then take the top nibble, rotate it to the right by 4 bits, and then we store it back into D2. And then finally we take our definition again. We take the middle nibble this time here, and then we rotate it to the left. So effectively we've moved the red component to the left here, and we've moved the green component to the right here, all within those respective registers. Now we need to combine all of those registers together. So we add D2 and D3 to D1 by ORing them in. And now D1 contains our full definition within the Neo Geo palette definition. Of course, these top bits are potentially usable, but as I say, we don't use them within these tutorials. These tutorials only use 1 nibble, 4 bits per channel. So we then just write to the palette definition. Now, in most of our tutorials we'd be done at this point, but because of that background color, we do want to do a little bit more this time. So what we're going to do is we're going to check if the color we're changing is color 0, the background color. If it's not, then we just return. If it is, then what we're going to do is we're going to set that common background color, which is stored at 401 FFE, to the same color. So we're effectively setting color 0 of palette 1 and the backdrop color at the same time. And then one final addition is that by default, when the system boots up, the off-screen areas of the screen are colored in with color 2 of the palette 0, and if we don't set that, we will see them show through. Just run that out here, and then if I change this to a blue here and we just run this again, now you can see what we've got here is these ugly black strips here, because these are effectively that border color, and although if we do fully clear the screen they would go away, by default they don't. So what I've done here is I've just added this extra entry here to set that color as well, being as it's not being used for anything else. And now you can see those vertical strips are gone. So as I say, just a little addition there to get rid of those default strips to make everything a bit neater. Anyway, that's really all there is to the basics of setting the colours on the Neo Geo. We're going to be looking at the Neo Geo again later in the future to look at the very advanced sprites the Neo Geo has. Of course, the sprites can also use all of these colours, so the Neo Geo really is a very, very powerful graphical system, at least in a 2D sense, and that's why it was, you know, literally arcade caliber. Anyway, I hope you've enjoyed this. If you have, please like and subscribe, because that always helps. Thanks for watching today anyway, and goodbye.